Okay, now for example 6, we're finding the distance between two locations. Let's return to this situation introduced at the beginning of the section. Okay, Tracy set out from Elmhurst, Illinois, to go to Franklin Park. On the way, she made a few stops to do errands. Each stop is indicated by a red dot in Figure 1. We want to find the total distance that Tracy traveled. Compare this with the distance between her starting and final positions. Okay, now the first thing we should do is identify ordered pairs to describe each position. So if we set the starting position at the origin, we can identify each of the other points by counting units east, right, and north up on the grid. So for example, the first stop is 1 block east and 1 block north, so it is at 1, 1. The next stop is 5 blocks to the east, so it is at 5, 1. After that, she traveled 3 blocks east and 2 blocks north to 8, 3. Lastly, she traveled 4 blocks north to 8, 7. So we can label these points on the grid as in Figure 15. So here are those points. Next, we can calculate a distance and note that each grid unit represents 1,000 feet. So from her starting location to her first stop at 1, 1, Tracy might have driven north 1,000 feet and then east 1,000 feet, or vice versa. Either way, she drove 2,000 feet to her first stop. So what it means is she could have driven this way 1,000 and then up here 1,000, or she could have gone up this way 1,000 and this way 1,000. So regardless, she has driven 2,000 feet to get to 1, 1. Now her second stop is at 5, 1. So from 1, 1 to 5, 1, Tracy's going to drive 1, 2, 3, 4. That's 4,000 feet. Because again, one unit represents 1,000 feet. Now her third stop is at 8, 3. So there are a number of routes from 5, 1 to 8, 3. Whatever route Tracy decided to use, the distance is the same, as there are no angular streets between the 2 points. So let's say she drove east 3,000 feet and then north 2,000 feet for a total of 5,000 feet. So if she drove 1, 2, 3,000 and then up 2,000, that's 5,000. Or she could have driven up 2,000 and then to right 3,000. Now, lastly, her final stop is at 8, 7. So this is a straight drive north from 8, 3. So going up here, 1, 2, 3, 4, that means she's driven 4,000 feet to 8, 7. So now what we're going to do is we're going to add the total distance and then write it in a table. So from 0, 0 to 1, 1, the number of feet driven was 2,000. From 1, 1 to 5, 1, the number of feet was 4,000. From 5, 1 to 8, 3, the number of feet were 5,000. And from 8, 3 to 8, 7, the number of feet driven was 4,000. So when we add those all up, the total amount of feet that's been driven is 15,000 feet. Now, in step 4, the total distance Tracy drove is 15,000 feet, or 2.84 miles. This is not, however, the actual distance between her starting and ending positions. We want to find the distance. We can use a distance formula between the point 0, 0 and 8, 7. So rather than trying to find the distance of how she would go this way, we want to find out what is the distance straight from 0, 0 all the way to 8, 7. So by doing that, we're going to use the distance formula. So d is going to equal x2 minus x1 squared plus y2 minus y1 squared, where x1 is 0, y1 is 0, x2 is 8, and y2 is 7. So let's plug in that value. So we have 8 minus 0 squared plus 7 minus 0 squared, which becomes 64 plus 49. That becomes the square root of 113. When we take the square root of 113 on our calculator, take the square root of 113, we get 10.63 units. Now, keep in mind here that 1,000 feet per grid unit, the distance between Elmhurst, Illinois, and the Franklin Park is 10,630.14 feet. Well, how do we get that? Well, we take 1,000 and we need to multiply that by 10.63. And that's going to give us that result for in terms of feet. So again, if we take this number and then multiply it by 1,000, and that's how we're getting 10,630.14 feet. Or you can convert that to miles. Now the distance formula results in a shorter calculation because it's based on the hypotenuse of a right triangle. A straight diagonal from the origin to the point 8,7. Perhaps you've heard the saying, as the crow flies, which means the shortest distance between 2 points between a crow can fly in a straight line even though a person on the ground has to travel a longer distance on existing roadways.